Greetings! We're in Unit 4, Module 2, Session 1. The name of this home connection is Think Before You Add. Place your name and number at the top of the paper, and let's begin. Number 1 says to study each problem before you begin to solve it. Think about which strategy would be most efficient, right? And what do they mean by that? Easiest, fastest. Choose your strategy and solve the problem. Use the space below the problems if you need it to do your figuring. In other words, use this blank area for scratch paper. 99 plus 43. One observation that I might make about that number is that 99 is really close to 100. So when I see a 99, and I might say, well, maybe I want to add 1 and take away 1 to make these numbers more friendly. Remember that if you do some addition or taking away, you have to do it to both sides. If you add to one, you got to take away from the other. Okay, the same number. So if I add 1 to 99, I get 100. If I subtract 1 from 43, I get 42. Is that a little bit easier to add? 100 plus 42 should be 142. I'd say so. And by looking at this for a minute before I jumped in, I found maybe what you might say is the most efficient, your easiest and fastest way to do it. And maybe that wasn't your fastest, but it was your easiest, and that's okay too, right? All right. I look at these numbers and I say, ooh, gosh, maybe I want to do expanded form for all of these. So maybe I take 878 and I break it into 800 plus 70 plus 8. And I break 121 into 100 plus 20 plus 1. Now, this might not be the fastest or the easiest for you, but I am going to show you all of these just in case. So 800 plus 100 becomes 900. Okay. 70 plus 20 becomes 90. 8 plus 1 becomes 9, which gives us a really fun number. 999 is our answer. Okay, so I kind of used my expanded form and then added down. You might like that. Give that a try sometime. All right, then I see this one over here and I go, oh gosh, you know, 213, that doesn't round very well. 262, that doesn't round very well. So maybe I just want to use the standard algorithm for addition, and I add 3 plus 2 and I get 5. 1 plus 6, 7. 2 plus 7 is 9. Sorry about that. And then you add down, right? That one worked out really well. Didn't have to carry. That's okay. I would recommend you use the standard algorithm for this last one, which you're going to do on your own. As you do it, you'll notice that you are going to have to carry a 1 with one of those digits, okay? Pause this video and work on that question. 2 really wants you to use only the standard algorithm to solve these problems, and I'm only going to do one of them with you, okay? I'm going to zoom in even closer just so we know what we're working with. Standard algorithm, I'm going to start on the right side. 9 plus 5 is 14. What do I do with that number? Well, I usually say 14 carry the 1, so I write 14. Remember, if you're adding 2 digits together, you will never carry anything higher than a 1. Now this changes if you're multiplying or if you're adding more than 2 numbers, but if you're adding 2 numbers, you'll never carry more than a 1. If you do, something has gone wrong, okay? Now let's add down again. 1 plus 8 is 9. 9 plus this 1 is what? 10. Carry the 1. Okay, so now I have 1, 1, and 2. Add those together and I have 404 for my answer. So as you go through these problems, some of them will be 2-digit numbers, 3-digit numbers. You're going to have to do some carrying on all of them. Now, you might not carry every time, but you'll have to carry at least once. Now pause this video and give this a try, okay? And when you're ready, we'll do number 3. Look at the problems in item 2. Find a problem that might have been solved faster with another strategy. So I'm going to look at all of these and go, which one of these have I done faster than using the standard algorithm? This is kind of tough. You know, as I look at this one, I go, well, 57, that's close to 50. Maybe I could do expanded form. Maybe not. 497, that's really close to 500. Maybe I could try that. Expanded form might work really well on this one. Okay, but I'm going to choose this one right here. Okay, which problem, it says down here, which problem did you choose? And if I take this question, I'm going to rewrite it down here. Okay, 378, 497. That's the problem. Which strategy could be faster? We might say give and take. Now the reason why would be that 497 is really close to 500. Okay, and you could get more detailed than you say 497 is really close to 500, which is a very friendly number, and you could write that in. It's a really easy number to work with. But that's maybe the only reason I would do a give and take, is because you can easily give and take to find numbers that you can combine very fast. Now, it doesn't tell you to solve it, but what if I just really quickly, what if I do 497? I'm going to write this down real quick just so that you can see. Right? If I add 3 here, I have to take away 3 here. Then I would have a 500 on the bottom and a 375 on the top. When I add that down, 5, 7, 8. That actually isn't too bad when you add those down, right? So that is a pretty fast way to do it. Could be about the same, and that's okay. On the back page, this is where things are going to get a little bit more interesting. As you look at this one, you're going to notice, oh man, I think we did this in Unit 3. Oh man, I think we did this in Unit 2. And that is true. Just a little bit of mixed review, okay? Remember, when you're looking at greater than, equals, or less than, the alligator always eats the bigger number, okay? So, first off, as I look at this first question, I'm going to notice that the bottom numbers do not match. That is a problem because we can't compare them unless they do. But look at this. 3, I can turn 3 into 6 by doubling it. So if I double both of these numbers, I get 4 sixths. Now if I compare 3 sixths and 4 sixths, way easy to tell that the alligator is going to eat the bigger number. So because there are 4 pieces that are this size, this has 3 pieces that are the same size. Okay, so 4 of them is 1 more than 3 of them. Okay. When it comes to numerators that are 1, here's your review. You can just compare the bottom number, and then you just have to figure out, is a smaller number bigger or larger? Okay, how do I figure that out if I don't know? Well, what if you draw it up top? Let's say that I take a fraction like 1/2, and I compare it to a fraction like 1/4. Which piece is smaller? 1/4 is. So that's proof that the bigger the bottom number, the smaller the piece. Now, if you want to get even more clever with it, think about anything you might share with somebody, like a candy bar. Like, I love Hershey bars, right? And I don't exactly remember how they look, but maybe they look something like that. The more pieces I cut it into, the smaller they get, right? So if you had to choose whether you wanted, 2 out of 9 pieces or 6 out of 9, well, you know how to do it that way. But if I took the same candy bar and I divided it this way, well, you know that if you wanted a bigger piece of a candy bar, breaking it in half would be better than breaking it into 9 pieces. So if I look at here and I say which number's larger, it has to be the one with the smaller denominator. Because breaking something into 3 pieces, those are bigger than breaking something into 4 pieces. This is the last one I'm going to do with you, but take a look. We're having some issues. These bottom numbers, the denominators, do not match. How can I make them match? Well, let's start by doubling the larger one. So this would be 10/12 if I double it. Can I turn 4 into 12? Yes, I can by tripling it, because 4 times 3 is 12. So I'm going to triple both numbers. Triple the 3 and you get 9. Triple the 4, you get 12. Now I can compare these fractions because the denominators match. Which one has more 12ths? Alligator eats the larger number. If I were to end up with 10 and 10, they would be equal, right? Just to make sure you're aware that some of these might be equal. Pause this video while you work on the bottom line of number 4. Okay. Here it says, write the decimal name for each fraction. I like to say it before I write it. 5 and 9/10. 5 and would be our decimal, 9/10. Now here's my question. How do I know whether I'm going to do 9 like this or whether I'm going to do 9 like this? We know that the first digit refers to tenths and the second digit refers to hundredths. So if I want 5 and 9/10, it has to be the top choice. Okay? What about this next one? Use the information I just told you and help me with this one. 6 and 5/100. 6 and 5/100. Is that correct? No. Because if this is 5 and 9/10, this is 6 and 5/10. But this says hundredths. No, no, no. 6 and 5/100. Because this would be like 5 pennies, right? There's 100 pennies in a dollar. This would be $6.05, right? 5 out of 100. Let's do one more. 2 and 6/10. 2 and. We know that 9/10, tenths are right after the decimal, and hundredths are going to use 2 digits. Okay? You're focusing on the second. So here, 6/10 is going to be 2.6. That is 2 and 6/10. Pause this video and finish those, please. Use the examples that we just did to help you solve the remainder. Okay? Last year, Monica's snake was 9 and 62 hundredths inches long. I feel like my video is a little blurry. Sorry about that. Now her snake is 12 and 37 hundredths inches long. Show your work with numbers, labeled, sketches, or words for each question below. And we have 2. We have an A and a B. Okay? How much did Monica's snake grow in the last year? So we started at 9.62. And we grew to 12.37. Right? That's how our growth is the in between. How much do we add to 9.62 to get to 12.37? And that can be really tough to figure that out. That's why this is a challenge question. Now, if I add 1, right? Well, that would be 10.62. If I add another 1, that would be 11.62. If I add another 1, that would be 12.62. And now we're too big. So we know that our number is more than 2, but less than 3. Is that helpful? Well, maybe a little bit, right? So if we add 2 to this number, like we said, we get 11.62. How do I get to 12.37? Well, to get from 11.62 to just 12, let's say we're maybe using a number line. I'm going to move up 0.38, or you might say 0.38, okay? And then to get from 12 to 12.37, I'm going to move up how much? Well, this is 12, this is 12.37. I'm going to move up 0.37. When you combine both of these numbers with your 2 that we added on already, life should be good. So let's do that. 0.38 plus 0.37 is 0.75. Don't forget the 2 that we already added on, so our answer is going to be 2.75. If you are unsure about your answer, we could technically stack and add. We don't do this very often in 4th grade, but let's try it. I'm going to take my answer down a little closer so that you can see it. So I'm going to take the 9.62, and I'm going to put the 2.75 underneath, and we're going to check our work. 5 plus 2 is what? 7. 6 plus 7 is what? 13, carry the 1. 9 plus 1 plus 2 is 12. And this decimal has to stay in place. You have to drop that decimal down. You can't move it. Okay? So 12.37. Was that what we ended up with? Yes, it is. So that is how much it grew. 2.75 inches. Now, let's have some fun. The next question, if I can get this camera to focus, it says, how much more does her snake need to grow to be exactly 13 inches? So we're at 12.37. We're trying to get it to an even 13 inches long. Yeah, I'm going to do 13.00 just so that they look similar. So how do I get 12.37 to equal 13? I need to get this to add up to 100. So how much am I going to add to 37 to make it 13? Right? Well, if I add 0.03, excuse me. If I add 0.03, I'll have 12.4. Now I'm getting close. Now I just need to add 0.6, and that will get me there. So my answer would be 6/10 and 3/100, which would be the same as adding 63/100. That's a tough one. So tough. And if you don't like thinking of it as fractions, you could think of it as money. I have $12.37. How much money do I need to get $13? I need 63 cents. Sometimes you might find that to be a little easier. Okay? When in doubt, you can think of pennies and dimes. The tenths are dimes. The pennies are the hundredths. Okay? If you have any questions, make sure you ask a teacher or a friendly math wizard. Of course, they like to help you whenever possible. Check you later.